Good afternoon, lovely evening, night, everything to all of my beautiful men and women out there in the world. In this video, I'm going to be talking about section 5.4, which is all just about sum and difference formulas. These are your sum and difference formulas. Don't worry, you won't have to memorize them, okay? Because I know you guys are all worried about that. We're going to give you a little sheet of paper that's going to have all the sum and difference formulas, all the double and half angle identities once we get to those. So you guys are just going to have to know how to use it. Notice you have sine u and try that again. Sine of u plus v, so sine of u cosine v plus cosine u sine v. Okay, the u and the u correspond to each other, obviously, as well as the v and the v. These are coming from two different triangles, maybe sometimes, not always, but just notice they are two completely different angles. They will be different numbers that you will see. So, for instance, you'll have something like this, where it'll say sine of 135 minus 30. Well, yeah, this is just sine of 105 degrees, but you may not always have a calculator to calculate that. And since 105 degrees really isn't in our triangles, however, 135, the reference angle for 135 is 45, because it's 45 degrees away from the 180. 30 degrees is just 30 degrees, so we'll be able to look at our 30 degrees in our triangle. And the main thing that this section is going to consist of is just rewriting the formulas with the angles in the correct location. So using the angle identities that you guys hopefully wrote down, or you have that sheet of paper out in front of you, I can say sine of my first angle, so sine of 135, cosine of my second angle, so cosine of 30, minus sine of my second angle, cosine of my first. 135. That's not B5, that's 135. So with this, I can say sine of 135 degrees. Well, I have all sombreros, try chimichangas. So sine's in the second quadrant is related to the 45 degrees. So I'm going to have my 45, 45, 90 triangle where I have 1, 1, root 2. So this sine of 135 degrees, that will rationalize and reduce to 1 over root 2. I'm actually not going to rationalize it. Cosine 30, I have adjacent over hypotenuse, so square root 3 over 2, minus sine 30, sine from the 30 degrees, I have opposite over hypotenuse, so 1 over 2, and cosine of 135 degrees is going to be negative by your quadrants. Oh no, don't blow. And then from your 45 degrees, cosine is adjacent over hypotenuse, so 1 over root 2, and then 1 times square root of 3 is the square root of 3, like magic. Like magic. So you have 1 over, root 3 over 2 root 2, minus 1 times, well, I notice I have a negative, so a negative times a negative, this is actually going to be a plus. 1 times 1 is 1 over 2 root 2. So these things will simplify to square root of 3 plus 1 over 2 square root 2. And again, you guys can leave it like that. I'm not going to be bothered by it at all. Cool. Awesome. Done. I'm not dumb. It's okay, monkey. I didn't call you dumb. I said done. Here's a different kind of example that you're going to see where it doesn't have the angle already split up. However, trying to get this into things that I know that 150 degrees is a reference angle of 30. So if I do 150, that would leave me with 45 left. Well, I'm pretty sure that I know tangent of 150. I can figure it out. So that's our reference angle of 30. And I know I can figure out the 45 because that's 45, 45, 90 triangle. So I'm going to draw my triangles real quick. Yeah, look at how fast I am. So now with tangent, I have tangent of some angle plus some angle. So I'm going to use the identity where it's plus. So I have tangent of my first angle, so tangent of 150 plus, right? Yeah, plus tangent of 45 all over 1 minus tangent of both of them. So tan 150 and tangent 45. Okay, so then it's just a matter of figuring these things out. Hopefully you remember how to do this stuff. If not, you need to go back and relearn chapter 4 or do something. Help yourself out. So with 150 degrees, I know that is in the second quadrant. So that tangent is going to be negative, whatever it is. So I'm going to say negative. 150 degrees gives me a reference angle of 30 degrees. So tangent is opposite over adjacent. So this is negative 1 over root 3. And then I have plus tangent of 45. 45 is in the first, so it's positive. Adjacent over opposite, or opposite over adjacent is 1. And then over 1 minus. Those two things multiplied together. Because I already know tangent 150 and I got tangent 45, so there are only two things to really find. So negative 1 over root 3 times 1. So this is going to leave me with negative 1 over root 3 plus 1 over 1 plus 1 over root 3. Because we have the negative times the negative will give me the positive. 1 times 1 over root 3 is just 1 over root 3. And believe it or not, I'm going to be good with that. I will let this slide as an answer because I am confident that you guys know how to get a common denominator and rationalize if you needed to. So, happy birthday. All right, moving right along. Write the expression as a single term. We have sine of 140 degrees cosine 50 degrees and sine of 50 degrees cosine 140 degrees. So I want to condense this into a single term. Well, by my, let's see, where's my sheet? Where's my sheet? Where'd you hide my sheet? All right, I got it. So this one looks like the sine. I have a plus. I have a plus on top, so I'm going to use my sine function on top. So I can say that this is going to be sine of, I can have u and v. So sine of 140 plus 50. Well, 140 plus 50 is 190, so this is really just sine of 190 degrees. And that's all she wrote. It's written as a single function. Happy day! And yet another example. I only have a few more, so hopefully this video will end shortly soon. With this one, I have cosine of 15, cosine 45, minus sine 15, oh, that's supposed to say sine, my bad. My B-O! Not my B-O. I don't smell that bad, right? Yeah, as if you guys can smell me. That's probably for the better, though. And I'll stop talking about it now. Moving right along. I have cosine, cosine, sine, sine, so this looks similar to my cosine one. So I'm going to say that this is cosine of my first angle, opposite of the sine, so plus the other angle. Well, then that's really just cosine of 60 degrees. So in your triangles, you have 60 degrees. Across you have root 3, 1, and 2. So 60 degrees is in your first quadrant, so I don't need to think about anything, so it will be positive since everything is positive there. Cosine is adjacent over hypotenuse, so I have 1 over 2, and that's all she wrote. Or that's all he wrote. I'm not a girl. I think. Alright, this example is just a little bit different than everything that we've done before. Notice I have sine of u and cosine of v. These are two different angles with two different triangles. So just to kind of help us out, it says they're both in the third quadrant, so I'm going to draw a triangle in my third quadrant. Don't forget your reference angle, or the angle that we use, is to the x-axis. So there is angle u. Sine is opposite over hypotenuse, so I have 24. It went down, so that's negative, and 25 is my hypotenuse. By Pythagorean theorem, this will be 7. Since it moved to the left, it's the negative x direction, so I need to have a negative 7. For my V triangle, same thing. I'm going to draw a triangle in the third quadrant. V is my angle to the x-axis, so that angle right there. Cosine is adjacent over hypotenuse, so negative 3 and 5. By Pythagorean theorem, this will be 4, make it a negative since it goes down in the negative y direction. So if I want to find cosine of u plus v, I don't know how to add these angles together, but I do have the identity that says cosine of u cosine v, v, and minus sine u sine v. Okay, so cosine of u, look at your u. Also, well, no, it doesn't give it to us. So cosine of u, so from u, I have adjacent over hypotenuse, so I have negative 7 over 25. Cosine v, I have right here, it's negative 3 over 5, so I can say negative 3 over 5, minus, because that's minus, sine u is negative 24 over 25, so negative 24 over 25. You can get it from the triangles too, if you do sine opposite over hypotenuse, negative 24 over 25, but they already give you sine u right there, so I'm just copying it down, just letting you know. And then sine v, Go to v, do opposite over hypotenuse is negative 4 over 5. So now, when you simplify these things, when you multiply them together, you have negative 7 times negative 3 is 21. 25 times 5 on bottom is 125. Minus negative 24 times a negative 4 is 48, 96, so minus 96 over 125. So now I have 21 minus 96 all over 125. So I'm going to move this up over here. So I have 21 minus 96 is negative 75 over 125, which will reduce to negative 3 over 5. You can take 25 out of both of them. And that's it. You would come down to an answer like this. Buenissimo. Arrivederci. Okay, another type of problem that you're going to see is verify. This is basically like what we did in 5.2, and we were proving that one side equals another. I know in that section that we wanted to do the side with more stuff, and this side has more stuff, yeah, but the only thing I really see that I can do is distribute the 1/2. So what I'm going to do is I'm going to mess with this side. Since I see that this is an addition of angles, so I can do my sum and difference formulas. Well, this is going to be the sum for sine, so I can say sine of pi over 6. So this is like u, this is like v, and cosine of x plus sine of x cosine of pi over 6. And then equals. Again, remember that you can't just multiply, divide, do anything like that. You have to pick a side and work with it. So from here, thinking about your triangles, I have pi over 6 angles because I can't really do anything else. I don't really know what cosine of x is. It doesn't give me a triangle with an x. However, I can find sine of pi over 6 and cosine of pi over 6. So I'm going to look at my pi over 6 angle. So that side's 1, root 3, and 2. And sine is opposite over hypotenuse, so 1 over 2 times cosine x. So I don't know what cosine x is. And then I can do cosine of pi over 6, and I'm going to bring it up front so that adjacent over hypotenuse is square root 3 over 2, and then I just have sine x multiplied onto it. Okay, we'll check it out. It looks like what they did here to get this 1/2 out was just factor it out of both of these things. So I bet if we do the same thing, if we factor out the 1/2 from here and 1/2 from there, then I will have 1/2, oops, that's a cosine x plus square root 3 sine x equals happy days. You can also make it equal a pink monkey. Pink monkey! Pink monkey likes green bananas. Alright, last example I'm going to do for this section. It's another verifying one. The right side I only have 0, so I definitely don't want to work with that side. However, I see that this is a difference, this is a sum, so I'm going to use my sum and difference formulas. For this one, for cosine, I can say cosine of pi, cosine of theta, minus here, so I need to put a plus here, and sine of pi and sine of theta. Okay, so that is just coming from that one. I'm going to change colors so that you see that I'm going to also write this one. There's a plus in the middle, so I'm going to write a plus here. That doesn't really go with anything, but here's the formula for sine of an angle plus an angle inside. You have sine of u, so pi over 2, cosine v is theta, plus sine of theta cosine pi over 2 equals, hopefully it'll be 0. Well, these don't really, I don't know what to do here other than maybe I can figure out what this is and this is and this and this, kind of similar to the last one. So cosine of pi, that's not in our triangles, so don't forget about this little guy where you have 1, 0, you have the point 0, 1, you have the point -1, 0, and 0, -1. So cosine pi, pi is straight to your left. Here is your pi. I hope it's tasty. Cosine there is -1, so I have this is -1 times cosine of theta. Now check out what's going to happen here. For sine of pi is your y value. Y value is 0. 0 times sine theta, that's going to be 0. So that whole thing right there is going to go to 0. Okay, then I move on to the next term. Sine of pi over 2 is straight up, yo. So sine is your y value again. That's 1. So I can say this is plus 1 sine theta. Oh, no, 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 no. Oh, no. Oh, no. Hot potato. Hot potato. No. 1 cosine theta. Okay, and then move on to the next one. So cosine of pi over 2 is 0. So once again, we'll have a term that goes to 0. So now I'm left with negative 1 cosine theta plus cosine theta is, well, negative 1 plus 1 is 0, so this must be 0 equals, oh yeah. Hopefully this video was helpful for you guys. As always, thank you for watching, and I hope you have a wonderful evening.